Hello everyone, welcome to the course on solutions. In this lecture, we are going to discuss about the ideal and non-ideal solutions. So, as you already know, the solutions means these are the homogeneous mixtures of two or more components. Now, what does this ideal and non-ideal solution means? As you already know, the Raoult's law, that explains the partial vapor pressure is directly proportional to mole fraction. And if the given solution obeys the Raoult's law over the entire range of concentrations, then such type of solutions are said to be ideal solutions. Means the P1 partial vapor pressure is directly proportional to its mole fraction present in the solution. Then such kind of solutions are said to be ideal solutions. And these ideal solutions are having some properties like the enthalpy of mixing of pure components is 0. As you know, whenever we mix two or more components, then either the heat is released or heat is absorbed. That means the process is either exothermic or endothermic. But in case of ideal solutions, when two components are mixed with each other in order to form a solution, then there will be no release of heat energy or no absorption of heat energy is observed, and hence the change in enthalpy will becomes equal to 0. So enthalpy of mixing of pure components is 0 for ideal solutions. And another one is volume of mixing is also 0. That is delta V mixing is equal to 0. Means if we mix two or more components, at that time there will be no change in volume is observed. If we mix 1 liter of one component and 1 liter of another component, the change in volume will be 0. Means final volume and initial volume must be equal to 0. This type of solutions where the change in volume upon mixing is equal to 0 are considered as ideal solutions. And along with this, two components, suppose I have taken A and B components are taken. Now in A component, only A molecules are there, and those molecules interact with each other, and here we will observe AA interactions. In component A, we will observe AA interactions. And in component B, in a similar manner, you can observe BB interactions when they are present in pure state. Still they are not combined with each other. Upon mixing the component A and component B, the interaction between A and B takes place. So AB interactions will takes place in case of in the formation of a solution. Now if it forms an ideal solution, then the AA interaction, BB interaction, and as well as AB interactions, or you can say intermolecular forces, are same. No change in intermolecular forces will be observed. The whatever intermolecular force present between AA components will be same in BB as well as same in AB also. Okay, then such kind of solutions are considered as ideal solutions. So examples of ideal solutions, some of the few examples, they are approximately shows the ideal behavior. Those are solutions of N-hexane and N-heptane, benzene and toluene, bromoethane and chloroethane, etc. These solutions will nearly shows the ideal solution behavior. Not exact ideal solutions, but they approximately, nearly, they behave as ideal solutions. So this is all about the ideal solutions. Now the next kind of solution is non-ideal solutions. Non-ideal solutions we will observe in our day-to-day life, because all the solutions that we are observing or that we will use in our day-to-day life are examples of non-ideal solutions, because these solutions do not obey Raoult's law over the entire range of concentrations. Means they will not obey Raoult's law over entire range. At some concentrations they may obey, but at all concentrations they will not obey Raoult's law. And such type of solutions are considered as non-ideal solutions. And here, as in case of ideal solutions, the enthalpy of mixing will be 0. But in case of non-ideal solutions, enthalpy of mixing is not equal to 0. That means either heat is released or absorbed upon mixing of two components. Okay, means the process of mixing is either exothermic or endothermic. And another property or characteristic is delta V mixing is not equal to 0. Means change in volume is not equal to 0, because either the increase in volume is observed or decrease in volume is observed upon mixing of the two components. And the AA, BB and AB interactions are not same due to change in the interactions of these AA, BB and AB components. The change in volume is not equal to 0 and enthalpy change in upon mixing is also not equal to 0. This is because the interactions are not the same. But in case of ideal solutions, the intermolecular forces are same. So this is all about the ideal and non-ideal solutions. Now we will see the difference between ideal solutions and non-ideal solutions. Already I have told you what are the characteristics of ideal solutions and non-ideal solutions. Now simply we will summarize them and we will differentiate ideal and non-ideal solutions. So the first one, ideal solutions means they obey Raoult's law over the entire range of concentration. But in case of non-ideal solutions, they do not obey Raoult's law over the entire range of concentration. This is one difference. Then in ideal solution, change in enthalpy on mixing is equal to 0, and in non-ideal it is not equal to 0. In ideal solutions, change in volume upon mixing is equal to 0, and in non-ideal solutions, change in volume upon mixing is not equal to 0. And AA, BB, AB interactions are same, and in non-ideal solution, AA, BB, AB interactions are not same. These are certain differences which we can observe in case of ideal and non-ideal solutions.